All right, Unit 5, Day 9. We're going to talk about irrational and imaginary roots and the imaginary irrational root theorem. And our learning target is I can identify additional irrational or imaginary roots of a polynomial equation and then write that equation in standard form. So kind of building off something we already know, some of this is. But let's do some quick review. So if I took the square root of 3 times negative square root of 3, well, first off, positive times a negative is a negative, and then the square root of 3 times the square root of 3, well, if you think, the square root of 3 is what times itself equals 3, and then we're saying take that times itself, well, that equals 3. So this one's going to be negative 3. This guy here, I'm going to FOIL this out, and it's got a binomial, got two terms multiplied by two terms. What's special about these is that the signs are different between them. If you remember, we called those conjugates. And the cool thing about conjugates is stuff's going to wipe out. A whole bunch of stuff's going to wipe out. So when I FOIL the first, I got 1 times 1 is 1. And then the outer, that'd be a negative radical 2. The inner is a positive radical 2. So right there, those wipe out because a negative radical 2 plus a positive radical 2 is 0. And then I got radical 2 times negative radical 2, which would be a negative because a negative times a positive is a negative. But then radical 2 times radical 2 is 2. So 1 minus 2 is negative 1. 4i times negative 4i. Now remember, I is the square root of negative 1. So keep that in mind. So I've got a positive times a negative. That's negative. 4 times 4 is 16. I times I. So if I took I times itself, that'd be the same thing as I squared, which would be the square root of negative 1 squared, which is going to be negative 1. So I'm actually multiplying this by negative 1, which is going to make that positive. So this would be a 16. And then over here, again, binomials. So FOIL them. 2 times 2 is 4. 2 times negative 3i, that'd be negative 6i. But then the inner product is a positive 6i. So right there, those guys, that's 0. And then positive times a negative, we're multiplying these two, would be, a negative, and then 3 times 3 is 9, and then I times I is I squared, but we just said I squared is the same thing as negative 1. So 4 plus 9 is 13. I remember something like this, complex conjugate. There was a question on a test like that, and you had to find the answer. Now, there's this thing called an irrational root theorem. And it's just saying let a and b be irrational numbers, so a and b are any numbers that you could write as a fraction, and let the square root of b be an irrational number. So b is rational, but when I square root it, it's irrational. So like 15 would be an example. 15 is rational, but the square root of 15, that's irrational. Okay. Now 16 is rational, but the square root of 16 is 4, which is also rational. So that we're not talking about those. We're talking about ones you can't square root. You know, the numbers, all the non-perfect squares. So if a plus radical b is a root of a polynomial equation, so if this is a root, then the conjugate is also a root. That means a minus radical b has to be a root with it. No matter what, they come in pairs. Okay? So anything and its conjugate, if one is a root, the other one has to be a root too. Okay? So that's irrational. So none of these are irrational. Now imaginary is when you have i's instead of radicals. Okay, so if I, instead of having a plus radical b, what if I have a plus bi? Well, then the conjugate, which would be same thing, except for instead of a plus, it has a minus, is also a root. They come in pairs. Okay, so if I told you a polynomial equation, there's some equation out there that has roots 2 minus radical 7, 2 minus radical 5, and radical 7 as roots. That's not all of them. I just said that those are 2 of the roots. Well, there's 2 more I know for sure. The other ones would be the conjugate of this guy, which is going to be 2 plus radical 5. What would the conjugate of this guy be? Because conjugates have 2 things. They have something being added or subtracted. This is the same thing as 0 plus radical 7. So what's the conjugate of that? Switch the sign to be 0 minus radical 7, which is just negative radical 7. Okay? Number 2, a polynomial equation has these 2 roots. Okay, so find 2 additional roots. When you try to pause the video here, try this out. Try to write the other 2. Based on this answer up here, you use this as an idea. Try to find the other two. The other two, they're the additional roots that have to be roots also. Still waiting for you to write it down. Okay, so hopefully you did write it down. Maybe you waited me out. You knew that I eventually would write it, but so switch the sign. So if 2 plus 9i is a root, then 2 minus 9i has to also be a root. And if 7i is, then so is negative 7i. An equation has solutions, negative 10, 4i, and radical 3. So give any additional solutions that the equation must have. So again, pause the video. Write down any additional solutions that it has to have. Be careful, just write the ones that it has to have. Okay, so here's the other two additional ones. Notice negative 10 is not an irrational root or an imaginary root. Okay, negative 10 is rational. So negative 10 can stand alone. It can be by itself. But 4i has to be paired up with negative 4i. Radical 3 and negative radical 3, those are paired up when we're talking about roots of equations. So now we're going to take it a step further. So an equation has these two roots. State any additional roots, then we want to write the equation in factored form, then write in standard form. So we've got a few steps here. So first, any additional roots. Well, if it has 6, does it have to have negative 6? No, it does not. Those don't come in pairs. 6 is rational. There's no theorem about rational roots coming in pairs. But negative 3i is imaginary, and imaginary roots come in pairs. So that means an additional root, I'll put up here A, an additional root would be positive 3i. So that's my A. And then B, write it in standard form. So if 6 is one of my roots, that means x minus 6 is one of the factors. If negative 3i is one of the roots, then x minus negative 3i, which is going to be plus 3i. And then x minus the third root, 3i. Okay, now we don't want to leave it like that. We don't want to leave i's in our final answer. So what I'm going to do is I'm going to multiply these guys together. They are conjugates. Things cancel out when you multiply conjugates together. So I got x minus 6. When I multiply this guy, I got x times x is x squared. The outer and the inner are going to cancel out. Negative 3i plus 3i. I'm sorry. Negative 3ix plus 3ix wipe out. And then I've got a negative 9i squared, which is actually plus 9. Okay, so we don't ever leave i's in our answer. We don't want them to be imaginary. So there's nothing imaginary about this. Here's the factored form. And then for part C, how about standard form? Well, I just multiply these together now. I've got to multiply all out. So FOIL this guy out. So x cubed plus 9x minus 6x squared minus 54. Now, if I put it in standard form, the powers have to go in order. So if I had x squared or x cubed first, the x squared must come second, and then the x's, and then the constants. So there's the standard form. Okay, an equation has a solution 3 plus 8i. Find the other solution. Well, the other solution is the conjugate. So 3 minus 8i is the other solution that has to come with it. So at the very least, this is the other solution. So here's my two solutions. 3 plus 8i, 3 minus 8i. Now to write that in factored form, I'm going to take x minus the root. And this is where it gets weird. Up here, 3i was just x minus 3i. Negative 3i was x minus negative 3i, which is x plus 3i. But I'm going to subtract a binomial. So I've got x minus 3 minus 8i is one of them, and then x minus this root. You might remember when you're subtracting a binomial, you have to subtract both terms. So when I got x minus 3 and then minus negative 8i, that's actually x minus 3 plus 8i. And this one is x minus 3 minus 8i. So there's my factored form. They didn't ask me for factored form, they asked for standard form, which kind of stinks, but it's fine. We're going to go ahead and multiply it all out. So x times x is x squared. X times negative 3 is negative 3x, and then x times negative, so that'd be negative 8xi. Now I'm going to take negative 3 times all of these. Minus 3x plus 9 plus 24i, and then take 8i times everything. plus 8ix minus 24i minus 64i squared. A lot of stuff's going to cancel here, so look around. Here I've got a negative and a positive. They cancel each other out. Positive and a negative, they cancel each other out. I got an I squared here, that's actually plus, so plus 64. And now put it all together, so the highest power I see is an x squared. I'm going to put my x's together, so that's negative 6x. Put your constants together, so 64 plus 9, that'd be 73. Okay? An equation that has a solution, 1 minus radical 2i, name the other solution, well, that'd be 1 plus, I don't know what I'm saying here, radical 2, I think I said an I in there somewhere. 1 minus radical 2, the other solution would be 1 plus radical 2. And then find this form in standard equation. So this is one root, there's the other root, x minus, I'm going to subtract 1 plus radical 2, 1 minus radical 2. So this will be x minus 1 minus radical 2, x minus 1 plus radical 2. And now multiply it all out, which I'm actually going to stop my video just to cut this time so I don't spend so much time talking here, but I'm going to multiply this out. You go ahead and pause your video and try to multiply that out. And once you're all done multiplying, you get this guy. Let's see, an equation has these two solutions. Write the other two and then find it in factored form. That's nice. I don't have to multiply it out this time. So here's one solution. That means, well, I'll just write this down. So here's, the first solution, the second solution. Another solution would be radical 7. Another solution would be negative 2i. So I'm going to write this in factored form. X minus this one would be actually plus radical 7. I'm going to write this one next. X minus that radical 7. X minus 2i. X minus negative 2i. Okay? Now again, this is not even factored form though, because I've got irrationals and i's in here. So I do need to multiply these two together and these two. Them being conjugates makes it kind of easy. So I got x times x is x squared. The outer and the inner are going to cancel out, so I just got to do the last. So this would be a negative 7, because radical 7 times radical 7 is 7, and a positive times a negative is a negative. Over here, x times x is x squared. Outer plus inner are going to wipe each other out. I've got a negative 4i squared, which is actually plus 4. And that's good enough. That's your factored form, so you can stop right there. Okay, the last guy, again, it says write in factored form, so that's nice. So the equation has these solutions. Any additional, the additional one would be negative radical 6. So now when I write in factored form, I have x minus the first one, x minus the second one, x minus the third one, and x minus the last one. We don't want any radicals left in our answer, so I'm going to have x minus 4, that's fine. X minus 5 is fine. Now multiply these together. Again, outer plus inner are going to cancel each other out. So I just got x times x is x squared. Outer plus inner is gone. Minus, and then radical 6 times radical 6 is 6. So that would be the factored form right there. So read it carefully what it's asking for. We like factored form better than the standard form because that's less work. But just read it carefully, the directions are asking. And your assignment for this also, the assignment for this, it'll be on Math Excel. I'm sorry, I'm thinking of something else. Never mind.